Hi, my name is Aruna from Group 8 and my group member's name is Nur Nabila, Afifa, and Akila, and Tashki. So we are going to present about the water level in Malaysia. This study focuses on 5 states, which is Pahang, Terengganu, Selangor, Sarawak, and Kelantan. Water level is an important indicator of water resources and flood risk in Malaysia. Changes in water level can affect water supply, agriculture, and nearby communities. And also, these states are often affected by heavy rainfall and monsoon seasons. So, QGIS is used to map and analyze spatial data to better understand water level distribution. And then, the map helps identify areas that may be vulnerable to flooding or water stress.
For this technical demonstration, I will explain the process of mapping water level data using QGIS and converting the result into WebGIS application. First, I use QGIS version 3.44 as the main GIS software. The spatial data includes Malaysia administrative boundary obtained from GADM. The water level data was collected from an official source, and OpenStreetMap was used as the base. Next, I imported the administrative boundary shapefile into QGIS. I then zoom into my selected area of interest, which is Kelantan, to focus the analysis on the study area. Next, I imported the administrative boundary shapefile into QGIS. I then zoom into my selected area of interest, which is Kelantan, to focus the analysis on. After that, I open the attribute table to examine the existing fields and ensure the data structure was suitable for further analysis. After that, I open the attribute table to examine the existing fields and ensure the data structure was suitable for further analysis. After that, I open the attribute table to examine the existing fields. Then I added a new field in the attribute table to store the water level values. The data was entered based on the water level dataset, allowing the environmental information to be linked with the spatial boundaries. To visualize the distribution of water levels, I create a chloropet map using the graduated symbology. Different colors represent different water levels, ranged across the study area. To visualize the distribution of water levels, I create a chloropet map using the graduated symbology. Different colors represent different water levels, ranged across the study area. To visualize the distribution of water levels, I create a chloropet map using the graduated symbology. Different colors represent different water levels, ranged across the study area. To visualize the distribution of water levels, I create a chloropet map using the graduated symbology. Different colors represent different water levels, ranged across the study area. To visualize the distribution of water levels, I create a chloropet map using. This slide shows the final chloropet map output. From the map, we can clearly observe spatial variation in water level within the selected area. Next, I use the QGIS to Web plugin to convert the desktop GIS map into a WebGIS format. The map was exported using the left-click option to produce an interactive web map. This slide shows the final chloropet map output. From the map, we can clearly observe spatial variation in water level within the selected area. Next, I use the QGIS to Web plugin to convert the desktop GIS map into a WebGIS format. The map was exported using the left-click option to produce an interactive web map. This is the WebGIS output. User can interact with the map by zooming in and clicking on each area to view detailed water level information. In comparison, Desktop.js is more suitable for detailed data analysis, while WebGIS is more effective for sharing and visualizing information interactively. This is the WebGIS output. User can interact with the map.
Hi, my name is Ain. Today I will explain the application to environment or spatial problem. What is application to environment? It aims to analyze the water level of river in several selected stages such as Sarawak, Pahang, Perlis, Selangor, and Terengganu that we do. This analysis is carried out to detect environment issues such as floods, water resources management, community safety, and river ecosystem. For spatial problem, you can see differences of river water level, distribution of high risk and low risk area, and relationship of river location with settlement and land use. Okay, next I will explain for detailed problem related to water level in selected district in Sarawak. As you can see, have district in Sarawak have two area in red color, meaning is the area have the high intensity water level. Kapit, the longest river in Sarawak. River water level rise easily, high risk of flooding in inland area. The wide river flow and low topography on the river bank cause water stagnation in some area. The problem that will come a disruption of river transportation, safety of resident and damage to property. For Limbang, that near in Brunei, problem faced by rising water due to heavy rains plus overflowing tributaries. Low-lying area cause flash flood. As a result, agriculture is affected, infrastructure is damaged, and transportation access is limited. GIS is an application that contribute a lot of nowadays. Look at this slide. I give two examples of Sarawak and Pahang. Exactly. GIS help to perform spatial mapping of data according to selected area. Analyzing regional differences such as difference in water level between district and stage. Also, analyzing risk area based on river water level GIS analysis result can support river management planning and flood mitigation. For my last part, I will show the real impact of using GIS in flood management. In Malaysia, GIS is widely used by agencies such as DID, NADMA, and local authority to reduce flood risk. By mapping river level and flood-prone area, GIS support early warning system that help community prepare before disaster happen. It also help planner make safer and land use decision and improve river and infrastructure management. Overall, GIS has a real impact its ability to spatially identify flood risk area, thus supporting mitigation measure, development planning and population safety protection. Thank you. That's all for me.
This slide shows a comparison between desktop GIS like QGIS and web GIS platforms such as ArcGIS Online, Mapbox, and Leaflet. Desktop GIS has advanced tools but a steeper learning curve. It's a powerful for analyzers and works fully online, which was useful for our project. WebGIS is more beginner friendly and accessible through browsers. It's a great for sharing maps online and handling large data sets using cloud storage. But it also allows plugins and scripting, while WebGIS has more limited options. Lastly, QGIS is free and open source, while some WebGIS platforms require subscriptions. Overall, both tools have their strengths depending on the task. But for this project, QGIS was more suitable for technical mapping and offline work. This slide shows the strength and limitation of desktop GIS and web GIS tools. Desktop GIS like QGIS is really ideal for technical users. It gives full control over data, symbology and plugins, and it also works offline, which was very useful for this project. WebGIS platforms are really great for sharing maps online, and it's also easy to use and support real-time collaboration, but they don't offer deep analysis tools and need internet access. For this project, we use QGIS to map the AOI and add the data of the water level. WebGIS was not used, but it could be helpful in future projects to publish maps online. Combining both tools would allow us to do analysis and also share results with the public, which is useful for environmental outreach. Thank you.
Special data was added into QGIS using the add data function. The dataset was successfully loaded and checked to ensure correct projection and visibility for further analysis. In this picture, some layers were turned off to avoid crowding map, and this helps to improve clarity and allows the main thematic layer to be clearly visualized. In this step, the attribute table of the ADM layer was examined. Existing attribute information such as administrative names and codes was reviewed. A new attribute feed was added to improve data organization to support further analysis. The map was exported from QGIS to web plugin and converted into a leaflet-based web map. Leaflet allows the map to be displayed interactively in a web browser without the need for GIS software. I applied symbology to improve map readability by using switchable colors, classification and labels. This helps users easily understand spatial patterns and difference across the study area. A correlate map was created by classifying administrative boundaries according to attribute values. Graduated color symbology was used to represent different data range, allowing clear visualization of spatial patterns and variations within the study area. The web map includes interactive features such as clickable pop-ups, layer control, and zoom tools, enhanced user interaction, and map usability. The web map includes interactive features such as clickable pop-ups, layer control, and zoom tools, enhanced user interaction, and map usability. The web map includes interactive features such as clickable pop-ups, layer control, and zoom tools, enhanced user interaction, and map usability.
Okay, now we are in the ending part of this presentation, which is conclusion. QGIS effectively displays water level variations across the 5 states. Differences in water levels can be clearly observed between Peninsular Malaysia and Sarawak. Areas with higher water levels may have a higher risk of flooding, especially during monsoon seasons. These results can support flood management, early warning system, and planning. Overall, GIS is a useful tool for improving water resource management in Malaysia. That's all from us. Thank you.